Hi, everybody. So these two questions were asked to do as a video solution. So here we go. Let's see. Here's the first one here. Looks like a parallel circuit. And one thing I know about parallel circuit is that the voltage is all the same. I've got two equations really that I can work with. One is that the voltage is equal to the current multiplied by the resistance. Or the other one I got is that the power is equal to the current multiplied by the voltage. Which is also, I could say I squared times the resistance, which I could also use is V squared over R. So all of these are true. These are on your equation sheets. And yeah, so this is Ohm's law. This is the power equation. And then basically, if you plug in Ohm's law into different parts of the power equation, you get these. So, okay, let's go ahead and try and solve some stuff. So again, parallel circuit, I know the voltage is all the same. So if I know the voltage across the battery, 20 volts, then I know the voltage across every single resistor here. This is going to be 20, this is going to be 20, and this is going to be 20. Okay, well, let's see. So now, down here, I know that power... right? Power is equal to the current multiplied by the voltage. So I can find the current because it's going to be I equals P over V. So the power is 12. The voltage is 20. And that's going to give me something. 12 divided by 20. 0.6. I could have got that. Oh well. 0.6 amps. So this is 0.6. Okay, moving right along. I can now get this resistance as well, R3, because I know that that resistance using Ohm's law is going to be V over I. So R3 is going to be V3 over I3. So the voltage, again, is 20. We know that the current is 0.6. So 20 divided by 0.6 is going to be about 33 ohms. All right, let's see. So now going now here, I know the voltage and the power, so I can calculate the current. So the current is going to be the power divided by the voltage using that equation right there. So the power is 28 watts. The current, the voltage is 20. So 28 divided by 20, I'm getting 1.4 amps. All right, so that's going to be here, 1.4. Okay, and then I can get the resistance. So, whoops, sorry. So using Ohm's law, the resistance is the voltage divided by the current. So for this one, we know the voltage is 20 volts. We know the current is 1.4 amps. So let's go ahead and get the resistance. So 20 divided by 1.4. So it's going to be 20 divided by 1.4. About 14.3 ohms. There you go. So 14.3. Okay, there we go. Next up. Up over here, we got 20 volts. Let's see. Okay, so now it looks like I'm like, oh no, I can't do anything. However, I can go back over here and get the current through the battery. So the current through the battery, well, that's going to be using power equals I times V. That means the current is going to be P over V. So it's going to be 50 watts divided by 20 volts. And that comes out to 2.5 amps. Ooh. 2.5 amps right there. And so basically then, and this is something that we got from our lab, that's 2.5 amps that's going through here. But then here it's going to split. It's going to split some of its amps. So 0.6 is going to go to the right. And then whatever's left over is going to keep going up. And then it's going to split again. So 4 goes to the right, and then the rest goes up. So that's what I'm going to do. And basically what it amounts to is this. it basically says that the total current going through the battery is equal to I1 plus I2 plus I3, because we got 3 resistors. So the total current, which we found was 2.5 amps, is going to equal I1, which we found was 0.6, plus I2, which is 1.4, plus I3, which is what we're trying to find. Oh, wait, sorry, opposite. This is I3, I2, and then I1 we're trying to find. So let's replace. So basically that's like that. Actually, this should switch as well. Should have just rewritten the whole thing. So plus here, and then I1 is what we're trying to find. If you isolate all this, let's see, that's 2. So this is going to be I1 is 0.5 amps. Now that we got that, we're in the clear. So this is going to be 0.5 amps. And now I can calculate the power. The power here is going to be the current multiplied by the voltage. So it's going to be 10 watts, because it's going to be 20 times 0.5. And then lastly, to get the resistance is going to be the voltage divided by the current. So the voltage is 20, the current is 0.5. That means this resistance is going to come out to be 40 ohms. And there you go. So there's that one. Now on to series here. Well, let's see. It almost looks like you can't do anything because, well, one thing I know about resistors in series is that the current is all the same. However, I don't know any of these currents, and none of these, I got a bunch of blanks here, and it doesn't seem like I can really get anywhere, but this is the whole point of finding equivalent resistance. So I can go ahead and make a new circuit. I'm going to make a new circuit. It's going to look like this. Boop, 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 boop. And basically, this resistance, Req, is going to be as if I just combined all 3 of these into one resistor. Well, how do you add up resistors in series? You just literally add up the individual resistances. So that's going to be 7 ohms plus 12 ohms plus 17 ohms. Let's see, what does that come out to? 17 plus 12 plus 7. 36. So I get 36 ohms for resistance, and that's what this is equal to. So this is 36 ohm resistance. And then the battery is still the same. It's still going to be 18 volts. And so I can now find out what the current is going through the battery, because it's going to be this current right here. So the current going through the battery using Ohm's law is going to be the voltage across the battery divided by the resistance. So the voltage is 18 divided by 36. Pretty sure that comes out to 0.5 amps. So this is going to be 0.5 amps, and that means then now I can say, let's keep that there. Now I can say this is going to be 0.5 amps, this is going to be 0.5 amps, this is going to be 0.5 amps. And now I'm in the clear. Now this really just turns into, well, let's see. Here, the power is equal to the current multiplied by the voltage. So it's going to be 0.5 times 18, which is 9. So 9 watts is the power provided by the battery. And then over here, the voltage is going to be the current multiplied by the resistance. So the current is 0.5. The resistance is 7, so it's going to be 3.5 volts. And then the power is just going to be these two multiplied. So the power is the current multiplied by the voltage. So it's going to be 0.5 times 3.5. That's 1.75. Okay, then over here, the voltage is going to be the current multiplied by the resistance. So this voltage is going to be 0.5 times 12. That's 6. And getting the power is going to be the current multiplied by the voltage. So it's going to be 6 times 0.5, which is 3 watts. And then lastly here, so again, surprise, surprise, we're using Ohm's law again. So there's going to be V equals IR. So it's going to be the current, 0.5, multiplied by the resistance, 17. And you get, oh gosh, what's it going to be? 8.5, I think. Yep, 8.5 volts. And then lastly, to get the power, it's the current multiplied by the voltage. So it's going to be 8.5 times 0.5, which is 4.25. And there you go. You can always check yourself because the voltage is 18 volts and it should add up to the voltage drop across each resistor. So we got 3.5 plus 6 plus 8.5, and sure enough, that adds up to 18 volts. Okay, hope that helped. All right, bye.